elimination method here is creating matching but opposite coefficients. Coefficients are the numbers in front of the letters. So you want to get matching but opposite coefficients for a variable, then add the two equations in order to eliminate that variable. So your packet, I don't believe, matches mine quite. It's a little bit different. So look at this first one. Once you finish writing here, I believe this number should be different. So change it to match mine. Change it to match mine. The only reason is just that then we can solve for x and get a whole number. That's all. And then I believe there's a change in each one of these. So if you can study these three and just make the changes. Since they're changed on here, I don't remember what they were on yours. I think I wrote it down. So that 5 in the first one changes to a 7. Or, sorry, the 7 in yours changes to a 5, yes. And then this right here changes to a 4, so change that to a 4. And then this changes to a 6, and this a 6. So we'll just overwrite them, I guess. I'll show you why in just a minute. So right here, what we're looking for is equal but opposite coefficients. And in this first equation, you can see the number in front of the y is both, they're both 2, but they're opposite. So that you can just put a line underneath these two and you can add vertically. It's a really nice little method to use here. It's called making a linear combination of two linear equations. You just add these. So this would be 5x. The y's are gone, and you have 5x equals 15. And so we can quickly and easily solve for the variable x. Really easy, right? Just add vertically. What does x equal? 3, yeah. And even if it were a fraction like it was before you changed it, it's not a big deal to solve for x. And then you would go back and plug in that 3 to one of those equations and solve for y. So that's why we learned the substitution method first, is that you're still going to use substitution to solve this as well, but we're going to use elimination to get the solution for one of the two variables, either x or y. And then you would substitute this 3 in right here for x, or right here for x into one of the equations. We aren't going to do that now, but that's the next step that you would do. What about this one? What do you see that's equal and opposite in that second one? What's going to get eliminated? This is why we call it the elimination method. The x will get eliminated. We have an equal and opposite 3 in front of the x. So those, I mean, you could write it down. It's just 0x. 0x is still 0. Minus y equals negative 10. That's what we end up with when we just add vertically. All we're doing is making it a big addition equation. They're already lined up. So negative y equals negative 10. And then if I divide by negative 1, y equals 10. And then I could go back and plug 10 into either equation to get x. We're not going to do that right now. Good. This final one, if you look at them, there isn't anything that's equal and opposite. If I added the x terms together, I'd get 9x. If I added the y terms together, I'd get 8y. So nothing would get eliminated. But could I do something, just one slight change that would accomplish the purpose of getting equal? What is it?
You have to, like, you either have to multiply or divide by a number.
Yeah.
I hated doing this.
Okay. Brings back Batman. You do. There's a couple different ways you can do this. You could subtract this whole equation from the one above it, which we don't usually do, but you could. It would look like this. You'd go minus, and then you'd have parentheses. So you'd subtract each and every term, and then the y's would cancel out. Another way to explain that some teachers explain it, is you multiply or divide through by a number, as you said, and we would multiply through by a negative. And so that's equivalent to, and this seems to work better for a lot of students, is just to, it's still addition problem, but what they do is multiply through by a negative. So it's like they put a negative sign in each one, which is going to change this to a positive 3 right there. Okay, it changes all the signs. So they'll multiply or divide, it doesn't matter, through by a -1, and then add them. And then this time we get 3x, the y's are canceled out, and 3x equals +9. The trick to that one is make sure that you multiply each and every term of that equation by the number. Like if I only multiply the left side by -1, I'm not keeping the equations equivalent. I have to multiply the left and the right side by -1. A mistake a lot of students will make is not multiplying the right side by that same number. So in this case, divide by 3, and x would equal 3. And then you would go on and finish that up. So that's the idea behind it. You're looking to make this equal but opposite so you can add them and cancel out a variable. So that's called the elimination method. Let's do a full example here. Pretty easy one to start with. This first one here is set up perfectly for elimination. Like if I looked at this, there's no way you'd want to use substitution on this, because look at the y's, right? The number in front of the y's already equal but opposite signs. So if I just place a line underneath this, plus sign over here, and add vertically, 2x and 6x is 8x. The y's completely drop out, and 8x equals 17 plus -9 is 8. So 8x equals 8. Divide by 8 on each side. X equals 1. And then this time we're going to go ahead and finish the full example. Okay? So if x equals 1, I can plug 1 in for x in this first equation or the second one. I don't think either one, there isn't one that's any easier than the other, but plug 1 in for x and then solve this equation for y. So I'm subtracting 2 from each side here. So 5y equals 15. And then divide by 5, y equals 3. So my solution would be 1, 3. So that one we eliminated the y. Let's pick just one of the now you tries. Let's actually do the second one here, where we eliminate the x. So I'd like you to take this one, the second one right here, just add them together. Let's go ahead and try it right now. Should be able to solve for y in about 2 steps. Put a line underneath it, add them together. X is eliminated, hence the name elimination. And you should get y equals -2. Y equals -2. You're adding vertically, so -3y and -4y is -7y, 9 and 5 is 14. Divide by -7. 14 divided by -7 is -2. Now what? How do we get the x? Yeah, we got to plug in -2. And as you're looking at these two equations, is there one that looks easier to plug in -2 to than the other? Yeah, my thoughts. I don't think so. I think they're about the same. So we just pick one. We could pick the second one this time, just for fun. So we have 3x minus 4 times -2 equals 5. And then we have to solve this for x. So I have 3x plus 8 equals 5. So I plugged in -2 for y. Now I'm going to just finish solving this. Subtract 8 from each side. 3x equals -3. Divide by 3. X equals -1. So my solution is -1, -2. So that's the easiest example of elimination. It's where you have it already set up so that one of the coefficients of one of the variables matches but is the opposite sign. So there'll be a couple problems like that, maybe one. I think one problem like that in the beginning. I think number 1 or 3 might be like that. This is going back to what we did yesterday, actually, with substitution. We did this type of problem with substitution. This one lends itself perfectly to elimination. It says the theater club sells a total of 101 tickets to the play. So student ticket costs $1. Let's call student tickets X, and an adult ticket Y costs $2.50. Total ticket sales are 164. So how many student tickets were sold? So we're going to set this one up. This is going to be an elimination method problem this time. So the theater club has a total, or sells a total of 101 tickets. So X plus Y equals 101. That's my total equation. And my cost equation, can you tell me what my cost equation would be for this guy? If X is student tickets and Y is adult tickets. You know what it is? Go for it.
1x plus 250.
Yeah.
$2.
Yep, that's right. 1x plus 250y equals 164. That's it. And now as I'm looking at this, I'm going, man, this is, I mean, we don't really need to write this 1 here, right? If I take that 1 away, you can leave it in there, but this lends itself pretty nicely to elimination. It's kind of like that third problem over on the right on my very first example. These x's almost match, right? They almost match. I could make them match by taking this equation right here and multiplying it by -1 on each side, and then moving it down underneath this guy. So my new equation 1 would be -x minus y equals -101. So -x minus y equals -101. You could have multiplied the second equation through by -1 as well, but you would have gotten negative values on each side, which is fine. But it's probably a little easier if you multiply the first equation through by a negative. Put a line underneath it, plus sign right here. If I add together these two equations here and here, what happens to the x? Cancels out. 250 minus $1 times y. There's an unwritten 1 here. 250 minus 1 is 150y equals 164 minus 101 is 63. So 150y equals 63. And that 150 will go evenly into 63. Do you have, how many times is it going in? If I divide 63 by 1.5, 30, what is it?
42.
Oh, 42, okay. Yeah. Yeah, because it'd be 42 plus half of 42 is 21. That gives you 63. So 42 now, what did I just solve for here? Let's see. Solve for y, and y represents adult tickets. Of course, they asked for student tickets. But I know the total number of tickets they sold, right? It was 101. So it's just 101 minus 42 will give me the number of student tickets. So that is 59 student tickets. So 59 student tickets. So that's a kind of a one type of problem where you might use elimination on it rather than substitution. This now you try one is a slightly different. So I'm gonna, rather than just send you off to do it with you, and this will be the last one I do, and I'll tell you what your homework is here, based on how far we got. It says washing 2 cars and 3 trucks. So we could call the cars could be X and Y. I don't really want to use C and T. Those T's look like plus signs, so let's call it X and Y. Takes 130 minutes. So we have 2X plus 3Y equals 130. And then it says washing 2 cars and 5 trucks. So 2X plus 5Y takes 190 minutes. This time it's asking how long does it take to wash each type of vehicle. So this isn't a total and a cost equation. This is 2 different combinations of washing cars and trucks and time. And we can figure out how long it takes to wash each one. Notice that we have a 2x in each one here. I'll show you an easy way to do this. I can just go ahead and multiply through by -1 in this second equation. It looks like this. I'll do it in red. It's like taking and putting a negative sign in each one of those. And then go ahead and add the 2 equations together. And so if you add these 2 equations, the x's cancel out. 3 minus 5y is -2y. I'm getting concerned because I have a negative in here and we're talking about time, but we're going to be okay because 130 minus 190 is -60, so I have a negative on each side. So it's going to work out here, right? Divide by -2, divide by -2, and I get y equals 30. And so it's 30 minutes to wash a truck. So 30 minutes to wash a truck. And to wash a car, it's going to be, well, what I'll do oftentimes, see how I've doctored up this equation, I multiplied through by -1. A lot of times what I'll do is I'll plug the value I got into the equation that I haven't messed with, okay? So I would take this first equation, the 2x plus 3 times y, and that's the one I'll plug the 30 into. So we got 2x plus 3 times 30 equals 130. So 2x plus 90 equals 130. Subtract 90 from each side. So 2x equals 40. Divide by 2. So x equals 20 minutes to wash a car. And so don't back up yet here. And this is solving a system by multiplying one equation. So on this one, you'll notice that neither the x's nor the y's, the numbers in front of the x's or y's, match. We're going to go ahead and get the y's to match here. If you look at this one right here, if I want the y's to match, I need the number in front of the y to also be a 15. Now I could work on getting the x's to match, but I'd have to multiply this one right here and this one right here to get those to match, because 2 does not go into 7 nor 7 into 2. But in the case of the numbers in front of the y's, I have a 15 and a -5, so I could easily get those to match by multiplying the second equation through by 3. So take that second equation, multiply it through by 3, and I have a new equation, 21x minus 15y equals 51. Line it up with the other one. Put a line underneath it and go ahead and add them. So I have 19x equals 19, divide by 19, x equals 1. I'm going to take the first equation, the -2 times x plus 15y equals -32, plug in the 1, and finish solving here.
Surrounding in a circle.
Now in this final system, we're going to notice that we'll have to multiply both equations by a particular number to get the coefficients or numbers in front of the variables to match but have opposite signs. So if you look at this first one here, look at the 3 and 4 here. We got a 3 and a 4 here. I can't just multiply one equation by something because the 3 doesn't go into the 4 nor the 4 into the 3. We would look at the least common multiple of 3 and 4, which would be 12. 12 is the lowest number they both go into. For example, we notice 3 doesn't go into 4, so we would take 4 and double it up to 8. 3 does not go up into 8 evenly or without a remainder. And then we would go ahead and triple 4 up to 12. Does 3 go into 12? It does. So the least common multiple would be 12. So one option on this would be to multiply the top equation by whatever we need to multiply the 3 by to get 12, which would be a 4. So we multiply the top by 4 and the bottom by 3. Now we want them to be opposite signs, so we would choose a negative 3 for the top and for the bottom. So that's one option. We could eliminate the x that way. We also have another option. You may have written that down already, but we can come back to that one. Another option, you can just, if you already wrote that down, just leave it there. We'll go back and eliminate the x's. But another option would be to eliminate the y. Same deal. We've got 2 does not go into 3. If I take and multiply 3 by 2, bring it up to 6, 2 will go into 6. So the least common multiple of the 2 and 3 is 6. I can multiply this first equation by a 3 and the second one by a negative 2, which would accomplish the purpose of getting a 6 in front of the y on the top and a negative 6y on the bottom, and then those would be eliminated. So let's just go with what we started with here, since some of you have written that down already. Take the first equation, and we're going to multiply that by 4. Take the second equation, 4 on each side. Multiply that by negative 3. And we get two new equations. The new equation on the top is 12x plus 8y equals 4. And on the bottom we get negative 12x minus 9y equals positive 6. Put a line underneath them, add them. The x's cancel out. 8y minus 9y is negative y equals 10. Adding the 4 and 6. And so divide by negative 1, y equals negative 10. Then I'm going to take one of the original equations. I'm just going to take the top one. It's 3x plus 2 times y. I'm going to replace y with negative 10 equals 1. So 3x minus 20 equals 1. Add the 20 over, 3x equals 21. Divide by 3, x equals 7. So I've got 7, negative 10 as my solution. So that's the final example. Just to review, we've got, going back to the first one here, this one we noticed that the number in front of the y's was the same but opposite signs.
Soren Bybee, Raymond Scarlett, and Levi McCallum, please report to the attendance office.
The second one, we wrote a system of equations. We had to write our equations and then noticed that we had an x here and an x here. So same coefficient, just not opposite signs. So we multiplied through by a negative 1 for that top one, and then we're able to add them. This one right here, number 3, we noticed that we could multiply the bottom one through by 3 on each side and create an equation of 21x minus 15y equals 51. And add that to the top equation without changing it at all. So we were able to just multiply one equation through by something to get the y's here to match but have opposite signs. And then finally, on this last example, we had to multiply both equations by a particular number. We had to find the least common multiple of 3 and 4, which was 12. With that in mind, we've got to bump each one up to 12. We've got to multiply 3x by something to get a 12 in front of it. and we've got to multiply the 4x by something to get a negative 12 in front of it so that they will be eliminated when we add them. So those are the different examples. Hope this helps.